All right, welcome back. So I am doing another FRQ on curve sketching. Just like last time, I'll have two more free response questions to do for homework afterwards. So really quickly to go back over the curve sketching stuff we did 2 weeks ago. We talked about concavity. Concavity is the second derivative of a function. If you are concave up, it'll be kind of a U shape where you're curving up. So like these two that I have here. So curving upwards looks something like that. Versus concave down would be curving downwards. If you are decreasing, then your slope would be negative. So that means for both of these functions, our first derivative is negative. For both of these functions, my first derivative is positive.
Okay.
Okay, so here it is again. You can see that if I took the slope at one point, I would be able to create a tangent line, a line that only touches the curve at that one point to see what's happening with my slope. My slopes for both of these are negative. However, these slopes are increasing. So what that means is as I keep going from left to right, my slopes are getting bigger even though both are negative. So this right side is not as negative as the left side. Okay, over here, my slopes are increasing as well, but this time they're both positive. So my slope here on the left is not as big as my slope here on the right. Concavity is telling us the slope of the slope. So if your change in slope is positive, then you are concave up. If your change in slope is negative, so my slopes are decreasing, then we are concave down. Any questions on slope and concavity?
No.
No.
Okay. Okay, we also looked at critical points and points of inflection. A critical point is any point where the first derivative is 0 or undefined. So B, D, F, H, and J are all critical points. A point of
Yes.
inflection is any point where the second derivative is 0 or undefined and the cavity changes. So right now my concavity is changing at C, E, G, and I. So all of my blue points are points of inflection. All of my green and pink points are critical points showing on the graph. A relative extrema is a point that's higher or lower than the points around it. So that means the first derivative is 0 and the concavity is either positive or negative. If you have a relative minimum, my first derivative is 0 and the concavity is positive. So here at D, we are concave up. I'm going to blow this up. So at D, we have something that looks like this, where our function is concave up, and our slope is 0 at that point. So that would be a relative minimum. For a relative maximum, the opposite would be true. So I would be concave down with a slope of 0.
Okay.
For an absolute minimum, it's the smallest point that's showing. So the smallest y value right now is actually a. And my absolute maximum, the largest y value, is j. Okay, any questions on vocab?
Nope.
No.
Okay, cool. So I'm going to start with the FRQ and break out of this because, again, the pen's not quite working yet. Okay, let me throw this into the WeChat as well before I forget. So if there's a problem with the stream, you can follow along here, and I'll post that to the Skype chat as well. There we go. Okay. So we have this polynomial with a bunch of unknowns. So you can see I've got 3 variables that we're not sure on. 3 constant numbers, I should say, that we don't know. So that's A, B, and K. However, we're told that the function does have a local minimum at 1 and a point of inflection at -2. So I want to find the values of A and B. If I have a local minimum at x equals -1, what would have to be true about this function at x equals -1?
0.
The slope would be 0. Okay. So I'm going to derive this function first. So we could say f prime of x would be equal to what?
0.
Would be equal to 0 at -1, but in general though, so at any x point, what would the derivative be?
12x squared plus 2ax plus b.
Perfect. That k is a constant, so it will go away. And then at the point -1, our slope should be equal to 0. That was given. So I can set this equal to equal to 0 as long as I plug in -1. So I'm going to set that up really quick. It's 2a plus b. And we can simplify. So what should my final equation be here?
-2a plus 12 b plus 12.
Perfect. 12 minus 2a plus b should be equal to 0. Okay. And then we were also told that we have a point of inflection at x equals -2. So what does that tell us about the original equation? If we have a point of inflection at -2.
The second drive is equal to 0.
Right. Okay, my second derivative should be equal to 0 when x is -2. So I'm going to get my general form for the second derivative then. We've already got our first derivative here. So Oliver, if I derive this, what's going to happen?
4x raised to the third power.
I'm going to derive, not integrate.
Oh, 24x plus 2a.
24x plus 2a, okay. We were told that the second derivative at x equals -2 is a point of inflection, so we can say that has to equal 0 because there's no point on this polynomial where our function would be undefined. So that gives us 0 is equal to 24x plus 2a. And then we know that's true when x is -2. So we can use that to solve for a. Oliver, I'm going to have you keep going with this, I think. Solve for a for me.
So we put plus 48 on the left side and divided by 2
Okay, so a is...
is 24.
Okay, and then Junho, I'm going to jump over to you. So we can use your first section. If a is 24, I should be able to plug that in here and solve for b. So what is b?
12.
Not 12. I'll do this. 12 minus 48 plus b is equal to 0.
Oh, 36.
36. Okay. B is 36. Okay, so I've got A and B. The last thing we need to do is solve for K. Oh, actually that's it for A. Find the values of A and B. For part B, we'll solve for K. So if the integral from 0 to 1 of f of x is 32, then we should be able to find the value of K. Okay, so now we can integrate. Let me copy our equation really quick. So our original equation was 4x cubed plus ax squared plus bx plus k. And this was f of x. And then we were also given that the integral from 0 to 1 of f of x is 32. Okay. So how can I integrate this?
X over 4 plus 8x raised to the third power.
Okay. So you said x over 4.
Plus
Okay, so this would be, if I divide by 4, that 4 will cancel. So this would be x to the 4th power over 4 times 4, or x to the 4th. Okay, and then the next term?
plus ax raised to the third power over 3
Okay,
plus bx squared over 2
okay,
plus kx.
okay.
Plus c.
Plus some sort of constant c. I won't need that constant c because we do have bounds for this. Since I know that the integral from 0 to 1 is 32. So we could say 32 is equal to what happens when I plug this in for upper bound minus lower bound. So I'm going to do my upper bound first, and then we'll subtract our lower bound. And I'm also going to substitute for A and B. So we said A is 24, B is 36. 24. 24. And B is 36. We also said our upper bound is 1 and our lower bound is 0. Okay, so something like this. For this whole lower bound, I'm multiplying by 0 for everything, so I can just get rid of it. So that leaves me with this. I forget who we're on, so I'm gonna jump over to Junho. What's happening for if I simplify?
1 plus 8 plus 18 plus k. So 27 plus k.
Okay. So I've got 32 is equal to 27 plus k. Therefore, k is equal to what?
5.
Awesome. Okay, I'm gonna zoom out here. So that gave us A, B, and K. Is there anything else we need to do for B? Nope. Okay, any questions on anything we did for A or B?
No.
No.
Okay, I'm gonna check our scoring guides really quick. Okay, so for the first part, one point for the derivative, 12x squared plus 2ax plus b. Okay, that looks good. 1 point for the second derivative, 24x plus 2a. Okay. Sets the first derivative at -1 equals 0. Okay. Sets the second derivative at -2 equals 0. Okay. Solves for a and b, 24, 36. 24 and 36. Okay, so that's 5 for 5. For the second part, okay, anti-differentiation. X to the fourth plus 8x cubed. Okay. X to the fourth plus x cubed is 18. Okay, we're okay there. So we did this in multiple steps, but that's 8x cubed and 18x squared equals 27 plus k. Okay, so that's 2 points. One for our general form, one for 27 plus k. Solves for k.
This section is without calculator.
Yes.
Okay.
So that's 4 for 4, and we should be good. Okay. Any questions on anything we did?
No.
No.
All right. How do you guys feel about the connection here versus Skype?
Better, I think.
Okay. I'm gonna see if for next time I can broadcast on both of these at the same time. That way people could just pick whatever they want.
Okay.
Okay.
And we'll see how it works.
Well, I think I prefer Skype too, but I don't know.
I can leave it up to vote. So, Junho, do you prefer Skype or Zoom?
I don't really care. It's working fine with me.
Both are working fine. Okay. I guess I'll stick to Skype then. I've got a handful of students in my pre-calc class that were having connection issues, but if we ever do have connection issues, then I'll throw up a Zoom window.
Okay.
Cool. Thanks a lot.
Okay.
Bye bye.